Hello, and thank you for joining us today. Well, we have two great subject matter experts with us to discuss enclosed breakers, energizing construction and industrial sites with NOARK. I'm Owen Hurst, president of Kerwell Media's Automation and Electrical Division, and I'm happy to be here today as your moderator with Rob Farrell and Mario Reel. Today this webinar is going to delve into NOARK service entrance approved enclosed breakers, that provide great world-class solutions and industry-leading deliveries. They have a robust UL listed enclosure paired with advanced M-series molded case circuit breakers. These units are setting new industry standards and are designed for both indoor and outdoor environments. To quickly introduce our presenters, we have here Rob Farrell, who has been working in the electrical industry for some time, and I have had the pleasure of meeting on numerous occasions and has an extreme depth of knowledge regarding, the breakers and all of the solutions that NOARK has. He himself is the technical marketing director for NOARK, and he's largely responsible for raising awareness of NOARK across North America as a global manufacturer of medium and low voltage electrical components and industrial applications, specializing in providing electrical circuit protection and motor control solutions for OEMs, contractors, and distributors. Rob has recently taken on the role of R&D director with the goal of developing even more products that will and high quality standards that will provide you guys with more products and solutions. And then also with us today, we have Mario Reel, who is the operations director for NOARK, based out of NOARK's Mod and Distribution Center in Pomona, California. He has over 2 decades of experience in manufacturing, continuous improvements, and supply chain. Mario was focused on improving the supply chain and developing assembled products with a team of experts that adhere to the highest quality of standards and delivery times. So as we get going today, Rob is going to walk you through the features and ratings of NOARK's market-leading enclosed breakers, part of their circuit protection line. And then Mario will talk about NOARK's modification center and product customization in a number of their locations. And then finally, they will introduce us to some real-life applications and stories that will help things be put into perspective. Now, just quickly before I hand it over to Rob and Mario, a couple of housekeeping things. First off, thank you very much for all of you who submitted questions in advance. We will do our best throughout the presentation to answer all of those. Some of them as we go through slides, others at the end of the Q&A period. If you look on the right of your screen, you'll see a small control panel. In there is a question box. Please, we encourage you throughout the presentation to ask any questions you have. We have two fantastic subject matter experts here who know all about this stuff. So at your fingertips, you have people to answer your questions. So this is a great opportunity for you to submit those questions throughout the presentation, and Mario and Rob will do their best to answer them. We will be recording this presentation, and it will be shared after the fact for any of you who are hoping to get your hands on it after. For those of you who do stay with us for the entire presentation, there will be a draw at the end for the $250 gift card of your choice, and we will reach out to you if you were the winner after the fact. With that, I'm going to pass this over to the important people in the room here and let them start to walk you through all of this great information. So Rob, thanks again for taking your time to be here today, and I pass it over to you.
Thanks, Owen. Yeah, let me move through. I'll do a little introduction to NOARK and the broader organization that we're part of. We're part of a global manufacturing organization. It's been around since 1984. Currently, somewhere around $22 million worth of USD in sales worldwide. 50,000 employees. We operate in 140 countries. So it's a very large organization. The NOARK brand was founded in 2011, really to focus on the North American and the European markets. So NOARK is the North American brand of the parent corporation known as Chint. And in that respect, the NOARK organization has headquarters in Shanghai, in China. Our North Canada, US headquarters is in Los Angeles currently, and the European operation is based in Prague in the Czech Republic. Really, the focus for the first number of years has been on low voltage products. We started with some motor control products, and then over the last few years have been introducing more circuit protection, primarily molded case circuit breakers and power circuit breakers. In the last year, we've been introducing more medium and high voltage products aimed at the transmission and distribution markets for utilities and independent power producers around North America. So that's sort of the basic overview. Yes.
Rob, if you don't mind me just jumping in, just had a fantastic question come in really quickly, just because you're talking about locations and such. Where does NOARK manufacture its products?
Well, that's a good question, Owen. And actually, Mario is going to be covering a fair bit of that information in his part of the presentation. So I'll leave it for that point of the presentation. And then if there's deeper questions, we can answer them then.
Perfect. Thank you very much.
Okay. So really the value proposition for the NOARK organization is really the tagline you see at the top: excellent products, exceptional value. Because of the scale and length of time our company's been in business, we really are a world-class manufacturing operation. All of our factories are ISO 9000, and I've been to those factories, and they are truly world-class. They're clean, they're well organized, they're all adhering to lean principles. Research and development. So the company just took an even greater investment in R&D. And what we've been doing is decentralizing the research and development from the factory locations. And now each global region has a research and development function within it. So that's my new role. I'm heading up R&D for the Canada, US, and Mexico markets. So the company is very focused on developing products and developing products that are designed for the end markets that they're being sold into. North American distribution, again, this is another big commitment that NOARK has made to the North American market. The original distribution center and our head office is in Pomona, California. 2 years ago, we opened a warehouse site in Kitchener, Ontario to serve the Canadian market. And we have a smaller warehouse operation based in Houston, Texas. The idea there is that we'll always have stock. We're very committed to keeping stock and doing what it takes to supply our customers' needs. Okay, so just a quick overview of the product lines: low voltage to medium voltage and high voltage. Circuit protection, so this is miniature circuit breakers, folded case breakers, and UL 1066 power breakers. Industrial controls encompasses motor contactors and overloads, safety relays, definite purpose contactors, and pilot devices primarily. Power T&D, this is where we really are getting into the medium and high voltage products. So the products there are really aligned around high voltage transformers, so 130, 120 kV and up, anywhere up to 700 kVA. We actually have a site in North America with a 500 kV, 500 MVA transformer in it. So that's a sort of a new growing area for us. And then in low voltage power distribution, we're expanding also. And today's topic is really the first foray into that part of the market with enclosed breakers. We're also going to be introducing more assembled products in the year 2025. We'll be moving into panel boards, switchboards, and some switchgear.
Rob, there, if you don't mind me jumping in, we just had a great question come in. Thank you very much for addressing the medium voltage and high voltage. So just a question about really just about where to learn a little bit more, as you know, we recognize that you guys are diversifying into this, but not everyone was aware. So where do they find more information about your medium and high voltage products?
Sure. So, like I said, it's relatively new. We really started about middle of last year, but Sandra has done a great job in getting some information up on our website. So there's a new page on our website that gives you sort of the basic information on the T&D products, and over time we'll be expanding that as we introduce new products and have more information available. And then there's also an email contact, which is tdsales@noark-electric.com. So we'll have that information put up in the chat so that you can gather the links and be prepared to check it out.
Thanks so much, Rob. I just put that up in the chat area, so anybody that would like that information, they can grab it there. Thanks, Rob. Thanks.
Okay, so getting into today's topic, which is UL 489 enclosed breakers. So what is an enclosed breaker? As the name suggests, it's a circuit breaker that's enclosed inside a box. Enclosures in our industry are typically made of metal or more recently from plastic materials. And they're really there to both protect the equipment from things like dust and moisture and physical damage, but also to protect people from the live components that may be inside. Enclosed breakers are really used in basically any part of a power distribution system in low voltage. The NOARK products, as you'll see as we go through this, are designed for different environments, whether it's indoors, outdoors, or in an industrial dusty environment, and also are suitable for service entrance, feeder, or branch circuit protection. And I'll get into a lot of details on that as we go forward.
Thanks, Rob. I know you're going to jump into some more details, but we did just have 2 questions come in on this specifically. What would be the best, or in your opinion, what are the best vertical markets for the enclosed breakers?
Right. So, the markets that are most probably best suited, that this product is best suited for, is in the construction markets for service entrance breakers, or for feeder or branch circuit breakers that are required to be individually mounted within a facility. I'll be covering a lot of that in detail later, but that's the contractors and construction market is probably the biggest opportunity for these breakers, and then of course industrial end users will have requirements for enclosed breakers where they need a wall-mounted disconnect that may be close to a piece of machinery, or or for some other way to distribute power within an industrial facility.
Perfect, thank you. And just actually following up on that, and a little bit of the points that you made about the environmental conditions that they can handle. How are they designed to handle those, and sort of what standards obviously are they meeting to be able to withstand those environmental conditions?
Right. So the enclosure ratings are driven by the UL and CSA standards. In UL, under UL, it's UL 50, and they provide very detailed descriptions of the construction and of the testing requirements. And then one of those organizations must witness the testing. And this brings us to Type 1, Type 3R, and Type 12, which is what our products here are rated for.
Fantastic, thank you.
Okay, so I think I've covered most of this. The current product that we have on offer is rated up to 600 amps, voltage rating to 600 volts, so it's good for every part of the North American market in Canada or the US. As I said, type 1, type 12, and type 3R enclosures. And they use our molded case circuit breakers, the M series from M1 to M4. So the M1 frame is up to 150 amps, M2 up to 250, M3 up to 400, and the M4 brings you to the 600 amp rate. All of our enclosures have neutrals available, which I'll be showing you in a lot more detail.
Rob, if you don't mind, I do believe you're going to be addressing this coming up, but I did just get a question while you're looking specifically at that breaker, and it was, can you get a shunt trip with these enclosed breakers?
Yes, any of the accessories that we offer in the standard breaker line can be included in an enclosed breaker. Now, I've got to qualify that because what I mean is all of the internal accessories. So shunt trips, under voltage releases, auxiliary contacts, all of those internal accessories are perfectly fine to add into an enclosed breaker. External accessories, such as the motor operator, because it adds a significant amount of depth to the breaker and motor operator combination, it doesn't fit inside the enclosure. We are, however, beginning to manufacture some custom panels. And if you have an application that needs a motor operator, for example, then certainly give us a call and we'll find a way to make it happen.
Fantastic, thank you for that. And again, I kind of feel like we probably are going to be covering this, but as they come in, great to address them. So we've just had another one come in. Are there plans to increase the range of the Nema 4 or 4X? And then also, will these be offered at 800 volts? Sorry, I hit you with two questions at once.
Okay, so the answer to the 4X question is we don't have specific plans at this point in time. As we get our feet on the ground with the type 1, 12, and 3R, we'll probably expand that range in the future. But in the interim, we have some options where we can work with OEMs to make a customized 4X enclosure, or even in our own panel shop, we eventually will be able to do that. In terms of the 800 volt ratings, we have the 800 volt rated breakers. That's not those breakers in our enclosure is not part of our test program today. But again, if someone has an application for that, we'll find a way to produce it.
Fantastic, thank you.
Okay. So now talking about expanding the range, we also have coming very soon a 1200 amp enclosed circuit breaker. And so it comes in a type 12 3R enclosure. It uses our M6 breaker, has the neutral terminal just as you would expect. Because of the requirements of the code, we also will be offering ground fault protection and energy limiting maintenance switch with this offering. So more details to come. We'll make an announcement when we're ready to start taking orders for this.
Perfect, thank you. You kind of answered that, Rob. I was about to jump in because there were some questions about when it would be available and sort of orders and delivery time, but I think you nailed that there.
Right, thank you.
Oh, okay. Rob, if you don't mind, actually, we just got a few great questions if you don't mind there. Will all 800 amp and 1200 amp have a flange handle with aircraft cable operating?
Yes.
Okay, I like that. Can you purchase the empty enclosure by itself, and does the CSA and UL certification cover the electrician adding a loose breaker and neutral kit in the field?
Yes, on our standard enclosures up to 600 amps today, they are listed by UL and for CSA to be field assembled. So they're perfectly fine to be assembled by the customer.
Fantastic again. And I know that we are going to touch a little bit on ground faulting later, but there is just a question here about what's being used for arc fault reduction or arc flash reduction, sorry, on the 1200 amp specifically.
Right. So the our terminology for that is an energy limiting maintenance switch. And the accessory for the breaker, for the M6 breaker, is it's all passed through UL. We're just working on the final stages of putting it in production. So that's going to be called an ELM 20, and it'll be available as an accessory to the M6, and of course will be able to be included in the enclosed breaker.
Fantastic. Thank you for providing those details. That's it for now.
Okay.
Oh. Well, now that you've said ELM 20, Rob, you got another one coming in. So is the does the ELM 20 require control voltage?
Yes, it will. And if I remember correctly, and we can maybe confirm this afterward, it has a very wide range of input voltage. I'm thinking from 24 up to at least 240 volts. But maybe we can confirm that and put it in the chat later.
Perfect. Thank you so much.
All right, so that's the 1200 amp. So I'm going to move now into the selection process for enclosed breakers. So the first step is selecting the enclosure, and the catalog number nomenclature starts with an E for enclosed breaker, and then the next digits indicate the enclosure type. So 01 is a type 1, 12 and 3R, those are pretty obvious. Then the next step is whether you're going to use a neutral or not. So neutral is required where specifically for service entrance, but also for many other applications where the neutral connection in a 3-phase 4-wire system needs to come through to the parts of the power system below this breaker. So when you require a neutral, the neutrals are designed to match the maximum frame rating of each frame. So a neutral, 1A neutral, is made to go with an M1 breaker up to 150 amps. And you see in the table at the bottom, you can see the selection details for the neutrals. So a 1 is 150, a 2 is 250, and of course they align completely with the M1 and M2 breakers. And then you'll see the final digit, the A or the B, indicates whether the lugs on the neutral have a single conductor opening or a 2-conductor opening. And that's meant to match up to what the breaker has. Same with the M4. It has a single option available for the neutral selection. The M3, our 400 amp breaker, it's available with 2 different configurations of the lugs on the breaker. There's a single hole connector for a larger cable, and a 2-conductor connector for using parallel runs of a smaller conductor. So we give you the option of choosing a neutral that suits that particular breaker frame. Okay, so that's how you select the neutral. And then moving on, the next step is selecting the specific breaker. So it's the M series breaker, frame 1, 2, 3, or 4, depending on the amp range. Interrupting rating, so standard, normal, and high interrupting ratings. And the literature for the product has all of the interrupting ratings listed in it. Then of course you're going to select a specific amp rating of the breaker. In this case, all of the trips are thermomagnetic. Once we introduce the 1200 amp, we'll have an electronic trip in there as well. And then the number of poles, is it 2-pole or 3-pole? And then the last digit is always the same, meaning that the breaker comes with lugs included. Okay, so
perfect. Rob, just quick ones there, if you don't mind, Rob.
Sure.
Yeah, can you? Is it possible to reverse feed the breaker, incoming power to the load side?
Yes, the way that's regulated is through the certification of the breaker. And so our breakers are tested with no line or load indication. So they're perfectly capable of being fed from either the top or the bottom.
Perfect. And then this is just a question on some clarification, I think. So the neutral is not switched.
That's correct. That's correct.
Correct.
And that's I've actually got some information on that coming up in the detailed technical stuff.
Oh, perfect. And then just one other one. Do you have a plan to have an electronic trip on frames smaller than 1200 amp?
Yep, that's underway. The engineering program for that is in progress as we speak. I'm anticipating mid-year next year to be able to start introducing those new electronic trips.
Fantastic. And you've clearly hit on some great information here because the questions are coming. So what series have a draw out mount option?
We don't offer that in a molded case breaker. In our new switchboard construction, for a larger air circuit breaker, we can offer a draw out standalone circuit breaker in an enclosure.
Perfect. Thank you very much.
Okay.
That's it for now.
Yep. So now in the case where someone might want to order just the enclosure by itself, there's a separate catalog numbering system. So I wasn't totally clear in the previous slide. This is for selecting a completely assembled breaker. So you would build up this catalog number to order a completely assembled breaker from us. If you choose to order just the enclosure, there's a separate but related catalog numbering system for that. And what you'll see here is same kind of thing. It's X. 150 is the frame rating of the breaker that it's designed for. The 600 volts is always the same because we have 600 volt rating on them all. And then the enclosure type. So as you can see here to the right, it's pretty straightforward. An M1 type 1 is an X150 600 type 1. Okay. Similarly, when you want to order a separate neutral, this gives you the catalog numbering system, and I kind of touched on it before. So we'll just leave it out there, and if there's any questions, we can certainly address them.
Not at the moment.
Okay, and then the final bit here is the overall product selection. So this gives you an example of some of the fully assembled catalog numbering. So what we're showing you here is the current ratings and the catalog numbers that each would generate in the different types of enclosures. What's important to note here is what we put in the catalog isn't every single combination of an M1 frame with all of its, 30 or so individual amp ratings. So what we've listed in the catalog here are the most common current ratings. If you wanted, for example, a 15 amp breaker, you can build up this catalog number and place an order on it on us, and we would know what it is. But what we've listed in the catalog, excuse me, are kind of the most common amp ratings for each of the frames. Okay.
Perfect. Just a little touch on there. I know we already actually addressed shunt trips, but what about are there also another full range of accessories available, like bell alarms, under voltage releases, communications, motor operator?
Yes. Yeah. So everything you mentioned is available. The things that are appropriate for the enclosed breakers, like I mentioned before, are really the internal accessories. There's many other accessories, and we certainly can post our master catalog for the molded case breakers, which will give you a all the details on the accessories that are available.
Fantastic. Now, we just had a great question come in. This may be a little bit more of an in-depth question, or that maybe required a different time, but you know, could you just maybe just lay out really quickly the difference between the ACB and the M series circuit breakers, and just a little information on like the A series breakers having a higher ampere rating versus the M series limited to 1200?
Sure. So molded case breakers and power circuit breakers fall under two different standards, under UL and under CSA. So the standard for a molded case breaker drives much different ratings of the product compared to a power circuit breaker. And if you look at where they're used, it's pretty clear why the differences are. A power circuit breaker is typically used in large power systems, you know, above 2,000 amps. Our A series power breakers range in frame sizes from 2,000, 3,200 to 4,000 amps. And that's typically used in switchgear or as the main of a very large switchboard. And because they're so high up in the power system, they have to be able to withstand much higher interrupting ratings, and they also have to be able to withstand a fault for a longer period of time, so that it allows the breaker closest to the fault to trip first. So those are the primary difference between a molded case breaker and a power circuit breaker. We offer both, and in some ways they can be used interchangeably at the higher ampacity ranges. For example, the A25 has a 600 amp rating, but if it needs to go into switchgear, or if you need a draw-out version, that would be your product.
Fantastic. Thank you for answering that. And then just another one. For the breakers that fit into these enclosures for single phase use, do they need to be 2TL and not 222L, or can a T22L breaker fit?
So the 22L nomenclature in the catalog is for what we call a true two-pole. So it's a two-pole frame, and that's available in the M1 and the M2. The 2L version is a three-pole frame with two poles of current carrying parts, and that's used in the M3 through M6 styles. Both breakers can be put into an enclosure with these products.
Perfect. And I know we're going to touch on a few things later, but just roughly, maybe really quickly, what's your standard lead time on the enclosed molded case circuit breakers?
You know what? I think Mario's. I don't want to steal all of Mario's points here, so I'll let him answer that one.
Okay, yeah, and yeah, not a problem. And then I think actually Mario was going to cover, I believe, or we're going to touch a base on also some more future offerings, because we do have a question about whether power panels are in the scope of those future offerings.
Right. So yeah, why don't we why don't we move on to Mario, and then we can answer more detailed questions at later slides.
Fantastic. So thanks, Rob, for definitely answering the all of those questions that were coming in. Certainly not all of them necessarily probably expected, but providing some really great information there. So at this point, we're going to pass it over to Mario, who's going to walk us through what's going on in the actual modification centers for the enclosed breakers.
All right, appreciate it, Owen. Hello, everyone. Hope everyone's doing well. So I just want to take a few minutes and kind of talk about how NOARK can provide those short lead times, and also provide, you know, that great quality and service to our customers. So what Rob mentioned before, we do have 3 distribution warehouses in North America, one in Pomona, California, one in Kitchener, Canada, and one in Houston, Texas. We do source all of our breakers, our accessories, and our enclosures with our parent factory. This is just a great benefit for us, because we're able to plan, we're able to schedule, and we have direct communications with our factories. I know there's a lot of times with other companies, they do a lot of outsourcing, but you know, you see you run into a lot of issues. One, usually extends the lead time, and two, there's a lot of potential failures that can happen when you have so many vendors or so many sources. So it's just a great benefit that we have more of that control. Our supply chain team has a weekly meeting with our factories to discuss the schedule, discuss any pending orders, and if we necessary, to expedite any orders. We do test and certify the products for North America, and we do have a 5-year exclusive limited warranty. Part of our inventory management strategy is to have everything in stock to provide that great lead time for our customers. We do have a robust ERP inventory management system where we do have safety stocks. We do implement a demand forecasting. So not only are we ready to have the stock now, but we also are able to fulfill and replenish inventory as we get orders in the future. One of the biggest questions is lead time. So we do have a standard 2 to 3 week lead time, but we also we can expedite as available. Of course, that's really depending on the quantity ordered and our capacity. But anyone on the call now, I mean, right now is a good time because we do have plenty of stock in all 3 of our distribution warehouses, and we have capacity, so we could really get that from the order to your door in 1 to 2 weeks. And what Rob kind of explained too, we could purchase these as loose items, so you could also get the enclosure, the neutrals, or the breakers separate.
Mario, just if you don't mind me jumping in, just a question came in. Is there a price list for these new products for distributors?
There is a price list. You could go ahead and go onto our website and find a sales rep, and they'll be able to help you out.
Perfect. We will be sharing all of the sales reps' contact details in the upcoming slides for everyone, as well as in the chat. And then just one other one. Are breaker test reports available at time of order?
Rob, can you answer that? I'm not.
Yeah. So yeah, I think we can address that on request. Typically, a test report would come not at the time of an order being placed, but at the time of shipment. So for the A series power breakers that we assemble, we do run it through a full functional test, and a test report is available for those products. I don't think we've had a request for a test report on an assembled molded case. I mean, clearly there isn't a lot of testing because this is a field assemblable product, and so there's really not any testing that happens. But we could certainly provide documentation that says what quality processes it's passed.
Thank you.
All right, thanks, Rob. All right, next slide. I kind of just want to show the enclosed breaker assembly, what it looks like inside. We kind of talked about earlier, we do offer a type 1, type 12, and type 3R enclosure with the options of either a 1-hole or 2-hole neutral. We also provide options for 4 breakers, ranging from 150 amp to 600 amp. Now, if you look to the enclosure to the right, as you see, we do prefabricate the enclosure at factory. And to help with that lead time, they prefabricate it and then they send it to the assembly areas. And really, all we really have to do in assembly is just put in the breaker and the neutral, and it's ready to go. And then next slide, what we want to do is kind of show you a short video of the assembly process. And as the video goes, I'll go ahead and kind of talk about what's going on.
I think it's loading here.
All right. As you see, Bobby, our tech assembler, is opening up the box. You can see it's packaged to protect the enclosure. He does a quick quality inspection to make sure there's no scratches or dents. He unscrews the cover and And if people are wondering what kind of screws, it is a combo screw, which you use either a Phillips or a SQ2 build drip. You see he's putting on the M1 breaker. Those screws are just simple Phillips screws. Next, he's grabbing the neutral, which is our one-hole neutral. So he's going ahead and screwing those in. Those are also the SQ2 or Phillips combo screw. And then finally, he goes and puts the grounding screw right in the middle. As you see, we offer red glove service, not white glove service. After he's done doing that, he's go ahead and put the cover back on.
Perfect. You know what? As we're just watching the rest of that, Mario, if you don't mind, a couple questions that I'll ask first. Is the CSA label different from just purchasing the loose enclosure versus the completed assembly?
It is. There's different part numbers and item numbers that we offer.
Perfect. And what regarding the neutrals, do the neutrals have bonding capability to ground for service entrance rating?
I believe so. That's a technical question. I'll pass it on to Rob, but I believe so.
Hi, sorry, I had to shut the video off because the sound was drowning you guys out on my side. So yeah, I'll cover this in a little bit more detail, but yes, there's a bonding provision for ground in the neutral assembly.
Fantastic. And then just the last question that we got throughout the video was, are the torque requirements for the fasteners and lugs given in the info?
That's correct. That's correct. Once we put all the instructions into the enclosure for the breakers and the neutrals, so that I'll have all the information there.
Perfect, thank you. And one more question, maybe it's just a little bit outside. It's just based on asking if you have a specific one available. Do you have any A-series breakers that exceed 4,000 amp?
I'll take that one. At this point in time, no. We do have a development program for a 5,000 amp, and probably longer term we'll go to a 6,000 amp low voltage breaker. You know, my expectation is that's probably 8 to 14 months away to have the 5,000 amp frame.
Perfect. Thank you, Rob, for that. And yeah, we'll let you continue on there, Mario.
All right, sounds good. All right, so next slide, I just kind of want to share that we are a global manufacturing. So as you see on the screen, we have factories all over the world. Currently, we have 26 global manufacturing bases, 9 overseas manufacturing bases, and 3 metering factories. So why is this important, right? One, we do have the flexibility and options to manufacture all over the world. And then 2, it kind of showcases that we are NOARK as a large company with endless resources, endless options to provide our customers with the best products and the best delivery and service.
Perfect. And just with such a large network, what is the distribution network? How exactly is the sales working, just so that people know? I know we have put in a link to some of the regional contacts. Is that the best and only way to get a hold of you?
Yeah. Apart from the regional sales managers who are on the website, as you mentioned, we do have a large North American network of manufacturers, reps, and distributors.
Perfect. Thank you. And yeah, thank you very much, Mario, for walking us through all of that information. It's very, very valuable, and it's nice to see the full global aspect that you guys are approaching here. At this point, we're going to pass it back to Rob, who's going to walk us through some enclosed breaker applications.
Sure. So this photo recently came in from Patrick Woodham, our general manager. It's from his local community. I think it's at the backside of a small business. And really, I wanted to put it in here just because it really illustrates the the need for constant renewal of some of our products. This has clearly been in service for a long time. And if you look at it, would you really trust it with your electrical safety? So we're, the next few slides are going to talk about most of the components you see on here and how that relates to service entrance and the use of the enclosed breaker. So quick overview of power systems in North America. And I'm going to keep this focused on commercial buildings. I won't venture into residential. I won't talk too much about industrial. So the typical layout of a power system for a small or medium commercial building is the utility will supply a 3-phase 4-wire system from a Y-connected transformer. So that's what you see on the left-hand side here. This is all part of the utilities power system. Utility power systems are not regulated by the by electrical codes or even even some they don't even have UL standards for some of the things that are done there. So this is all outside the purview of the National Electrical Code. That 3-phase 4-wire system you see here has a grounded neutral. An important concept in these power systems, and this is all driven around safety, is that there's a system ground. This system ground is a physically grounded product. It usually is ground rods that are driven into the ground or grounding plates that are buried in the ground. So that provides a very solid connection to earth for this power system. And then from the service entrance point, you move through the distribution and power system, and you go from successively larger circuit protection devices, maybe through a transformer, and eventually you get to the lowest end, where the consumers are consuming power. And so if you notice in the diagram, the neutral runs from panel to panel and provides that neutral connection depending on the type of power you need. But also the system ground is connected to what's called bonding, and every enclosure needs to be bonded to that ground system. The reason for that is if you've got a fault way down here at the bottom end of the power system, that bonding to ground provides a very low impedance path back to ground, and it makes this breaker operate very quickly in the event of a fault. The other thing that the bonding to the enclosure does is it ensures that the enclosure and the person touching it doesn't become the lowest impedance path to ground. Okay, so this is all designed for safety, and this grounding is very important, and you'll see where this system ground comes into play as we start talking about service entrance.
Rob, just a quick question about the enclosure and its size. Just curiosity question came in about some of the extra space in the enclosure. Is there a reason for it?
Yeah. So the standards for enclosed breakers, in fact, for most enclosed products, including switchboards and motor control centers, there's something called the wire bending space. And this is driven by the UL and CSA standards. And it means that you have to provide a certain amount of space between the terminals of the breaker and the side of the enclosure, and that space, the amount of that space is driven by the size of the cables that are coming into it. And it's really meant to ensure that someone working in that space, putting cables into the enclosure, has enough room to work effectively, and that they don't, damage cables and cause a safety issue when they're trying to squeeze them into a small space.
Perfect. Thanks for answering that quickly. I'll let you get back to it.
Okay. Okay, so there's a lot of information on these slides, and I'm going to go through some parts of it very quickly so I can focus on the important bits. If you look at that power distribution system, that what you see in red here is all owned by the utility. Of course, in Canada, it's 600 347 volts. In the US, it's primarily 480 277. And then the terminology in the code talks about a service drop and a service point. So the service drop is owned by the utility. The service point is the place where the utility's ownership ends and the utility customers' ownership of the equipment begins. And then that leads us into the service entrance portion of the system. So what I'm showing here is what's called a hot sequence metering system. The utilities typically specify what they want in terms of metering. So in hot sequence metering, the utilities power comes and joins onto these service entrance conductors. And in this example, and this can come in different forms, but in this example, which I tried to keep simple, the power flows through a utility metering cabinet, which only houses the utility's current transformers and in some cases potential transformers. The utilities usually specifies the dimensions and the construction of that cabinet, and there's many manufacturers that make those cabinets. So that provides the utility with a place to meter the power. The owner of the building must supply this though, okay? Then the utility comes along and they'll put a meter in a meter socket that's connected to the secondary side of these transformers. The meter base must also be supplied by the building owner. Then the power moves from there into the service entrance disconnect. I'll talk a lot more about what a disconnect is and what that means. But this is where that system ground comes into play. And what you'll see is that I've shown a link here in the connection. When this enclosed breaker is being used for service entrance, the system ground conductor, so that's the wire that comes from that ground rod, must be connected to the neutral. And in order to ensure that the neutral is grounded at that point and only at that point, that's where that bonding conductor comes in that bonds the neutral to the ground. In non-service entrance applications, you remove that bonding jumper or bonding screw in order to ensure that the neutral is only bonded in the one place in the service entrance box. Okay, so then the power moves through feeder conductors. And in this case, I'm showing a splitter box. What you see here could be replaced by a switchboard or by a panel board. But functionally, they all operate the same way. The feeder conductors come into some sort of a splitter device, and then the branch circuit protection devices protect everything from there out to the loads. Okay. Just a quick note on the cold sequence metering. As the name suggests, rather than coming directly into the metering cabinet, the circuit comes in through the service disconnect first and then into the metering cabinet. And then this allows you to turn off this breaker and have no power in the metering cabinet. And again, this is totally the call of the utility on how they do it. Okay, so what I'm going to cover in the next slides is Article 230. There's 7 sections in Article 230. I'm really only going to talk about the last 3. And there's many clauses in each section, so I'm only going to talk about the ones that are relevant to enclosed breakers in each one. I'm going to talk mostly about the National Electrical Code based in the US. The Canadian Electrical Code Section 6 is similar in most respects. It's not identical, but what I would say to you is that the Canadian code drives the same product requirements in an enclosed breaker. So if anyone has deeper questions on the Canadian code, we could set up a call another time. Okay, so in Article 230, Part 5 defines service equipment, and there's two parts of it. The service equipment, the first part is really general, Clause 230.62, and it basically says it has to be enclosed with no access to live parts, and that brings you to the enclosure rating under UL 50. There's a new requirement in the NEC, which requires barriers for the line side, that's the utility side of the disconnect device. And you see on the picture to the right here, I've just highlighted where this barrier system would go. This is new in the NEC. To our knowledge, it's not been enforced in any state yet. But what it means is that we will have to add an accessory to our breakers that provides this barrier so that you can't contact live parts that are on the utility side of the disconnect. Part 6 is fairly general. It says a means of disconnect is required. It has to be in a readily accessible location, and it has to be marked as a service disconnect. And you'll see in the packaging for our product, we supply a label that says it's suitable as a service disconnect. Other really basic things, all of the poles of the disconnect must open together. And then there's this talk about the disconnection of the grounded conductor. So this is the bonding means that I talked about. In the case of this particular neutral assembly, the bolt that runs right in the middle of the neutral goes through the insulator and screws into the back of the enclosure. And this is what bonds the neutral assembly to the ground of the system. Okay. So that's one very misunderstood part of enclosed breakers in service entrance. The rating of the service disconnecting means. So this is a fairly complex clause in the code. Basically, what it says is that for very small services serving a single circuit. So think of you see them on utility poles where there's a cable TV box and it needs to have power. You'll see a very small load center. That'll be a service entrance load center, and that means that the minimum rating is 15 amps for that device. If that same small service is serving 2 circuits, then the minimum is 30 amps. And then for residential services, the minimum is 60 amps. And then equipment connected to the supply side of the service disconnect. So I'm not going to go into the details. There's about, 6 or maybe 8 exceptions. The general rule of thumb is that nothing can be connected to the utility side of a service disconnect. Now, the exceptions are for things like metering equipment, surge protection devices. There's a bunch of exceptions. But there's nothing there that's what I would call a consumer of power, of any significant amount of power that's allowed to be connected to the line side of the breaker. Okay, so getting into more details of the disconnect and the circuit protection. This is another. And I believe this is a national electrical code only. I don't think this is the same in Canada, but we can confirm that. There's another part of this that contradicts the beginning statement, which says each service shall have only one disconnecting means. So that's the very first statement in 230.71. Then it goes on to say there's an exception, which means that you can have up to 6 service disconnecting means. And the way this works is the service, as you see in this picture, comes up into a splitter first. That splitter must be rated as a service entrance device. I think it's actually the terminals inside. But then you can have multiple service disconnects on the output side of that splitter box. Okay. When those disconnects are being grouped together, they must be mounted together in a group. And again, there's some exceptions, but generally speaking, you need to mount them all together in one place. Okay. Getting close to the end here, so I know we're at the end of our time. This is the last part of it where I'm going to talk about the circuit protection requirements. So each ungrounded service conductor must have overload protection. So that means a circuit breaker or fuses. The circuit protection has to be integral to the disconnecting means. So that means it has to be inside the box. And with a circuit breaker, of course, that's all inside the circuit breaker. Where a service disconnect is inaccessible to the end user, it requires a second disconnect device to be included in the system. So if this service entrance breaker had to be mounted inside a locked room that the end user couldn't access, then the code requires a second disconnect device to be mounted downstream of it, and it must have a lower amp rating so that this one trips before the service device would trip. Okay. So just let me catch up here. Right. So then the last bit here, yes. So the last bit here is ground fault protection. So any circuit breaker that's at 1,000 amps or greater requires ground fault protection. And the follow-on piece of that is clause C under 230.95. Those ground fault systems must be tested on site using primary injection means. So I'll just give you a quick overview of that. This diagram here to the right shows you how an electronic trip circuit breaker does ground fault. So you got the 3-phase currents running through the breaker. And then there's a sensor placed in the neutral circuit that's connected to the trip unit. The trip unit in the breaker measures the phase currents and any current that's flowing through the neutral, and it determines based on the relative ampacity flowing through each part of the circuit, it determines whether there's a ground fault or not, and it'll trip the breaker. The primary injection testing means that if the breaker has a push to test button that electronically makes it trip, that's not acceptable. And what you need to do is actually inject the full current through the primary side of this sensor. Okay, and that again is a relatively misunderstood clause in the code, and we've actually got an instruction for our air circuit breakers to help people understand that. And that's it for the technical part. We can get on to any other questions, I think, now.
Hi, Rob. Yeah, no, thank you for going through all of that very detailed information. So yeah, obviously we certainly have run just a few minutes over, but you didn't lose a single. Everybody stayed very, very engaged. Thank you very much for everyone staying with us. Maybe we'll just do one or two quick questions before we wrap it up. But so if we just pull on one or two of these quick questions here. So after the service entrance slides and their application questions, which includes service entrance label full-size neutrals. So no, you've already answered the Nema 4X. I think we answered a lot of these questions throughout here, Rob, as I'm looking at the ones that came in. I thought a service entrance rated required disconnects to have exposed knife blade type connections. Is this not the case?
this is not the case. The disconnecting means can be any suitably approved disconnect under the UL or CSA standards.
Okay, and then just one other one. So are there any, so is there a barrier for the service entrance enclosure, just to clarify on what you were talking about previously?
Yeah, so we're working on that. It's actually going to become a fairly high priority design program for us, because we were just working with UL and they informed us that early next year the UL 489 standard will include that provision. It's already in the code, so there's a little bit of risk that a local inspector will flag the lack of a barrier there. But it's our understanding that there isn't any jurisdictions that are enforcing that rule yet, because it's brand new in the code.
Understood. Well, you know what, Rob? I think we're probably going to end the questions there. You've done great, and you run over, and just thought I'd let you know you definitely have a number of people writing in saying thank you so much for all of the great webinar and for all of the valuable information. I do know that, because we run over, we're going to wrap it up. There may have been a few questions that got missed. We do know all the questions that were sent in, so if we didn't get to your question, please know that we will respond to you via email, and you will get a response to the question if it was missed. So thanks again, Rob, and definitely you have a number of the people all writing in. Thank you, great webinar, and appreciate both you and Mario taking the time out today to walk us through all this information.
My pleasure. I just want to give a shout out to Sandra and Kudmi for putting the logistics of this together. It's greatly appreciated. Yeah,
it's the team behind is always a big part of it. So certainly the entire team at NOARK was very valuable to putting this together. And so yeah, thank you to everyone. And thank you to everyone who took the time out of their day to be here with us as well. We certainly hope you walk away with some valuable information. And again, we will be in touch if we didn't get your questions, and feel free to reach out to us with any additional ones. So thank you so much, and everyone enjoy the rest of your day.
Thank you, everyone. It was fun.
Goodbye.